Okay, so let's start. So today we will solve the assignment 11 for the course Linear Algebra NOC 23 MA03. Okay, let's move to the first question. It is saying that let B be a finite dimensional linear product space and T be a linear operator on B and T star denote the adjoint of T. Then which of the following statements are true? First option is rank of T is rank equals to rank of T star. This is done in the class, so let me do it again. So the first option, so you know for linear operator T we can always write it in the product of elementary matrices, right? So T can be written as, suppose T has, let's say T has rank R. Or let's do it here. Let rank of TV equals to R. So then T can be written as T equals to E1 dot 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 ES, and these are identity matrix of order R 0 1 0 2 0 3. These are 0 matrix into F1 dot 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 FT, right, where EI and FI are the elementary matrices, where EIs and FIs are the elementary matrices. Right. So as T has rank R, so here we get identity matrix of order R cross R. And so if you this you can easily check that if you so now we have to take that conjugate transpose adjoint, right, conjugate transpose of the matrix. So what will, so now, so note one property, note that this will prove later I think question number 3, that for if A and B are two matrix and we take the conjugate transpose, then it will become B star A star, right? So using this we can, what, so if you take the conjugate transpose of T, then we will get T transpose. So here it will be FT star dot 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 F1 star into this will be conjugate transpose of IR. So here it will be O2 0 matrix of 2 1 O3, and here it will be ES star dot 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 E1 star, sorry, E1 star, right? So what will be the conjugate transpose of the elementary matrices? This is again not, conjugate transpose of elementary matrices are again the same, EI star equals to EI. This remains same under if you do the take the adjoint of this, right? Or no, sorry, they will not be remain the same, means adjoint of, they will not remain the same, adjoint of elementary matrices will again be, this will prove again be elementary matrices. This we will prove shortly, right? So then, so these are again elementary matrices. Therefore, rank of T star will be R, right? So rank of T equals to rank of T star. Right, so the first option is correct. So the first option we get that rank of T equals to rank of T star. So this is correct. Now what is the next option? If T is an isomorphism, so is T star. So right, so let's do it. So if T is an isomorphism, so is T star. Right. So this was done in the class that T star is again linear. Done in the class. T star is linear operator, right? And isomorphism means, and T is isomorphism means, given that rank of, suppose T is a map from Rn to Rn, so given let rank of T is n. So we will show as from option 1 we get rank of T star is also n, right? We get rank of T star is n, right? And T star, so let's say suppose T is a map from B to B, then T star, which is again map from, so let's B to W, then T star will be mapped from W to N, or here it is isomorphism, so let's take this 1 1 and 1 2. T is a map from B to B, so T star will be again mapped from B to B. Sorry. And it has rank n, right? So it means T is n, as B has dimension n we have taken, and let's also take dimension of B is n, because rank of T is n we have assumed. So rank of T star n, which implies T star is also an isomorphism. Also an isomorphism. Right. So if T is an isomorphism, then T star is also an isomorphism. So option number 2 is correct. Now what is option number 3? Dimension of V mod TV equals to dimension of V mod T star V. TV is the range of V under T. So basically range of T. So option number 3. Dimension of V mod TV equals to dimension of V mod T star V. So what is dimension of TV? This we have done earlier, as done earlier. Dimension of V mod TV. This will be dimension of V minus dimension of TV, right? and dimension of TB means rank of T, right? Dimension of V, this is dimension of range space, means this is rank of T, and we know the rank of T is rank of T star, so this is dimension of V minus rank of T star, right, by option A. So this is dimension of V minus, again this is dimension of the range space of T star V, so this is same as dimension of V mod T star V. This we have to prove, right? So the option number 3 is correct. Okay, so now option number 4 is T compose S adjoint of T compose S is T star S star. So this is not true. Here in the first option we have used it, right, that AB star equals to B star A star. So we'll prove that this is not true. So let's check that option number 4. What is it saying? T compose S star adjoint, this is basically is T star S star. So this is not true. It is not true. We'll show. Basically we will get S star T star, right? So let's, and as the operator do not commute itself, so let's see it. What is, so suppose let T is S is a map from U to V and T is a map from V to W, right? So let's compute this U, TS adjoint and W, right? Because T compose S is a map from U to W and T compose S adjoint will be mapped from W to U, right? So what it will be? So this will be TS by the definition of adjoint U W, right? So now, so this is associative, so T S U and W, so this you can write S U T star W, so which you can write U S star T star W for all U and W, right? For all U and W. So if this is true, then the by uniqueness of the adjoint, so then TS star will be S star T star, and as the operator composition is not commutative, so in general it is not equals to T star S star, right, in general. So the option number 4 is false. So this is false. Sorry, this is false. Now the option number 5 is T plus S star is S star plus T star, right? So let's again prove this. Option number 5. So again take T and S are both mapped from, T is a map from suppose U to V and S is a map from U to V, right? So then T star will be mapped from V to U and S star will be again mapped from V to U, right? So let's compute then this. Take a U T plus S whole star and V, right? So then what it will be? It will be again by the definition of adjoint, it will be T plus S UV, right? And by the linearity of the inner product, so this will be basically TUV plus SUV. Now again use the definition of the adjoint, so it will be T star V plus U S star V. So again use the linearity, so you will get S T star plus S star V, and then by the uniqueness of the adjoint for all UV, right, and then you will get T plus S star is T star plus S star, and addition is commutative, right? So this is same as S star plus T star. So therefore the option number 5 is correct. Let's move to the option number 6. What it is? For all V belongs to B, T star TB equals to 0 if and only TB is 0. Right. Let's prove this. So this is correct. Option number 6. T star TB equals to 0 if and only TB equals to 0. So first prove this converse direction. Let TB equals to 0. So we have to prove that T star, and because T star is linear, right? Yes. T star is linear. So T star TB will be 0, right? So which is same, T star TB is 0. So we get the converse direction. Now you have to prove the other direction. So you have to prove that if T star TB is 0, then TB is 0, right? So consider this, right? Consider this inner product TB TB. So then what is this? This you can write T star TB comma V, right? And this is 0, T star TB is 0. So this is 0 comma V, which is 0, right? So what we have got? T star TB is 0. Sorry. So TB norm square, which is this TB comma TB, which is 0, right? So norm of a vector is 0 implies the vector itself is 0, which implies TB is 0. So you get the other direction also. So the option number 6 is also correct. So option number 6 is correct, right? So question number 1 is done. Let's move to the question number 2. Okay. So it's saying that let A be a n cross n matrix with entries from the complex number, and A star denote the conjugate transpose. Then which of the following statements are true? Right. So let's do this. First one, it's saying that L of A conjugate transpose is L of A transpose, right? So L of A is the linear operator corresponding to the matrix A. So let's do this first one. So we have to, so let's say LA is a map from some vector space Fn of n dimension to Fm, right? And then and let beta be a, let beta be a basis of Fn. and gamma be a basis of Fm, right? Then LA conjugate transpose will be mapped from Fm to Fn, right? And with this basis, note also LA, the matrix of LA with respect to the basis beta gamma will be A, right? Because this is the linear transform corresponding to 2A. So then let's compute this LA conjugate transpose. LA conjugate transpose. So LA star will be mapped from. So this is a gamma to beta, right? So what is the matrix of a conjugate transpose? It is basically the matrix and you take the conjugate transpose of that, right? So this is done in the class, that this will be LA beta gamma, matrix of LA of beta gamma and the conjugate transpose of this. So this and this is A, so this is A star, right? And now what is A? A star means, so this is the LA star, LA star, it will be mapped from gamma to beta, right? So you get this, these two matrices are same, mean the linear transformation will be same. Therefore LA star will be LA star, right? So the first option is correct. Now move to the next option. What it is saying, determinant of A star is determinant of A. Okay. So we will show the determinant of. So determinant of A star equals to determinant of itself. But this is not true. We will show, right? Also this will be the conjugate of determinant of A, because A star is the conjugate transpose, right? And the matrix entries are from C, so it will basically the determinant of A and the conjugate transpose. So this you can check easily, that let's check the complex entries. Take A equals to 1 0 0 I, right? Then A star will be what? Conjugate transpose, right? 1 0 0 minus I. Then what is delta? Delta is I and determinant of A star is minus I. So they are not same, right? So the option number 2 is false. Now let's move to the option number 3. It's saying that A star of whole star is A. So this is again true. We will prove this. Right. So what we have to show, A star of whole star is the A. So right. So this is the matrix A. We have to take the conjugate transpose. Again take the conjugate transpose. We will get back it. So let LA be the corresponding linear transformation. LA will be mapped from suppose B to W, right? Then what will be the LA star? It will be W to B, right? So this we can write, the matrix is a map, so this we can view is a map from B to W, and also A star is a map from W to B. right? So now let's take this W A star so A star, a double star will be mapped from again V to W, right? So double star it will be take V. Then by the definition of adjoint it will be A star, right? W V. So this we can write the transpose of V A transpose W and the conjugate transpose, right? So then, and this again use the definition of adjoint. So this will basically A V W and the conjugate transpose. So this is again the same as W A V, right? And therefore by the uniqueness of the adjoint, therefore A star whole star is the A, right? So the option number 3 is correct. Right. Now what is option number 4? It is saying a trace of conjugate transpose is trace of A, right? So this is again will not be true. We will show that this is not true. So let's prove. And what is the next example? So we will show this both. Trace of A star will be trace of A bar or conjugate, right? So we will prove this. Means the fifth one will prove, then automatically the fourth one will be false. So we will prove the fifth one. So let's first prove the fifth one, then the fourth one will be automatically. So trace of A star is trace of A. What is trace of A star? So this is basically the sum of the diagonal entries, right? AI star of the stars, or the basically this is the conjugate bar, right? I equals to 1 to n. Let's say A is the matrix of dimension n. So this is the conjugate transpose of the same, right? I equals to 1 to n bar, and this is the same as trace of A bar, right? So therefore the fifth one is true, and the fourth one will be false, right? Because of the fifth one. So fourth one will be false by 5, right? So the fourth one is false. Now what is the option number 6? If the matrix A is an elementary matrix, so is A star. So that we have said in the first question, that we will so that the conjugate transpose of elementary matrices again the elementary matrices, right? So let's prove it. So this is option number 6. So let A be an elementary matrix. Let A be an elementary matrices, then we have to take the conjugate transpose. So there are 3 types of elementary matrices, right? So let A, this is row interchange, right? First one, interchange of 2 row. Right, interchange of 2 rows. So if you take the conjugate transpose, it will be basically the interchange of 2 column. Now because this is a conjugate transpose, you will get the transpose. So applying star, applying star, we will see that it will be, we can see it will be interchange of two column, right? So this is a, so which implies A star is elementary matrix. Right, because we have A is the interchange of two row from identity matrix, therefore A star will be interchange of two column from the identity matrix, therefore it is again elementary matrix. Type B, what is the multiplying by constant C? Multiplying a row by a constant C. Yeah, this time this is a constant is in complex number, right? So for the A star, it will be multiplying a column. C is non-zero, right? By the constant C bar, right? So which implies A star is again elementary matrices. So for the first two type we have done, and what is the third type of elementary matrices? It is just the add by a constant and add it to with some another row. So it will again be transformed into the column, right? So what is the third type of elementary matrices? Multiplying a row by a constant and add it with another row. Now for A star, what it will be? For A star, it will be the multiplying, it will be multiply a column by the constant, suppose it is C, by the constant C bar, this time it will be, and add it to the corresponding column and add it with another column. So this is therefore A star is again elementary matrix. Again an elementary matrix, right? So you have seen all three cases, and all three cases we get A star is elementary matrix. Therefore the option number 6 is correct. The conjugate transpose of elementary matrix is again an elementary matrix. So this is correct. So option number 2 is question number 2 is done. Let's move to the question number 3. Right. So what is question number 3? T be a linear operator on a finite dimensional vector space V over R. We shall denote the kernel of T with the null space of T. Then which of the following statements are true? Let W be a subspace of V, then W is invariant under T if and only W parp is invariant under T star. So let's prove this one. Right. So option number 1, what is given that W is invariant under T? Given W is invariant under T, right? So we have to show what is W parp. What is W parp? W parp is all such vector W dash in W or W such that W inner product with W dash is 0 for all W in W, right? This is the W parp. So we have to show that W parp is invariant under T star. To show W parp is invariant under T star, right? So we'll show that. So let's take W belongs to W, then consider this W inner product with T star W dash, right? Or W dash is from W parp. Yeah, okay. What do you mean by W invariant? Okay. So basically what we have to show. So invariant mean what? So W is invariant mean if W belongs to W, then TW belongs to W, right? So this is the meaning of invariant. So we have to show that W parp is invariant under T star. So to show if W dash belongs to W parp, then T star of W dash it will belongs to W parp, right? This is the meaning of invariant. If W dash is in W parp, then if you apply T star, then it will again in W parp, right? So this is the meaning under invariant, right? Did you get what is invariant definition? Okay. So we will show this. So let's consider this one. W inner product T star W dash, right? So if we show that this is 0, then T star W is in W parp, right? So we will show that this is 0. So what is this? So this is basically TW by the definition of adjoint and W dash. And as W dash is, so TW as W is invariant, TW is in W. So this is in W and this is in W parp. So which implies the inner product will be 0, right? Because it is in W, it is in W parp. And so this is in 0 means, and this is in W. So which implies T star W parp belongs to W parp, right? Because this is 0 means T star W, this should be in W parp. So we have started with the element which is in W parp. We have shown T star W dash is in W parp. So which implies W parp is T star invariant. So this is the first option. If W is subspace and W is invariant under T, so okay, we have proved one-sided, then W parp is invariant under T star, and you can reverse the argument also, right? So this is if and only if. So again you can reverse the argument. So this is the first way, and you can use the other way also. for the this part, so this will get the converse part. So this is the, so to prove the other part we have to show that, so given that what is given, the w dash belongs to w perp implies t star w dash belongs to w perp. This is given now this time, and to show what we have to show, w is given and w implies tw is in w, right? This we have to show. So let's again compute the inner product, tw with w dash. Then what it will be? It will be w t star w dash, and this we know this is in w and this is in w perp, right? So this is 0, and this we know this is in w perp, so therefore tw will be in w, right? So therefore tw will be in w, which implies w is t invariant. So this proves the both the direction. So therefore the first option is correct, right? Now let's, what is the option number 2? Range of t star perp is the kernel of t. So let's prove this. This is option number 2. What we have to show, range of t star perp is the kernel of t, right? This you have to show. So let's prove the one direction. Suppose so let's prove this first direction, this direction. Let w belongs to range t star perp. We will show that w is in the kernel of t, right? So kernel of t means we have to, so let's take this, consider this vtw. Then what is this? Consider this. Then it will be, right, t star v and w, right? And t star v is in the t star, it is in the range perp w. So t star v it is in the range of t, right? So this is belongs to the range of t, and w belongs to the range of t star perp, right? Oh sorry, this is range of t star. This is the range of t star, and w is belong to the range of, sorry, range of t star perp, right? So therefore this is 0, and so this is 0 for all b, right? Suppose this is in b, t is a map from b to w, sorry, w to b. So this is, if this is 0 for all v in w, which implies tw is 0, right? Which implies w belongs to kernel of t. So we get the one sided that, so therefore what we get, range t star, this is a subset of kernel of t. Now let's prove the other direction. Now this time let w belongs to the kernel of t. So we will show that w is in the range t star perp. So then consider this. T star v w, right? Then what it will be, v of tw, and tw is 0, right? W is in kernel of v and this is 0. So which implies, so if this and t star v is in this is in the range of T star, right? So which implies W belongs to range T star path, because this is 0 and this is in range T star. So therefore what we get? Kernel of T is a subset of range T star path. So the first one, so by 1 and 2, by 1 and 2, these two are same. What we get? Range T star path is the kernel of T. So option number 2 is correct. So this is correct. What is option number 3? Range T path is the kernel of T star. This will again be correct. Just apply, just replace T by T star. So let me write. So 3 by 2 we have, what we have? Range T star. Yes. Range T star, what we have? Range T star path is kernel of T. By 2, this we have. So replace T by T star. So then what? And use this, we will prove that T star whole star is again T. This we have proved earlier, right? So therefore, then what we will get? Range T path is the kernel of T star, right? So option number 3 is correct. Now what is option number 4? If TV inner product B is 0 for all V in V, then T equals to 0. So TV inner product B is 0, then T is 0. So this will show that this is not true. So here it is one important thing, that here given that T is a linear operator on finite dimensional vector space over R. So as this is over R, so this is not true. For complex vector space, this is true. So let's prove this. So this is option number 4. So TV B equals to 0 for all V in V implies T is 0. So this is false. Note that here B is a vector space over R. B is a vector space over R. And this statement is true for complex vector space. So let's give a counter example. So this is not this one. Because of this is false. So let's define T on R2 or on R2. What we have defined? T from R2 to R2. Define T of x comma y equals to minus y comma x. This is the rotation, means just this is the rotation by 90 degree anti-clockwise, right? So then note that. So let's any vector, how you can write it? So these are E1, this is it is 1 0, and E2 is suppose this is 0 1. So then any vector you can write c1 1 comma 0 plus c2 0 comma 1, right, because these are the basis of R2. Then t of xy comma xy. So this you can write. So what it will be? T of c1 1 0 plus c2 0 1 comma, sorry, so this is basically c1 and c2, right? Sorry, this will be here the x comma y. Not c1 c2 because these are x1 explicit. So this is x comma 1 0 plus y comma 0 1, right, comma xy. So then it will be x t of 1 0 means it will be t of 1 0 where it will map 1 0 will map to 0 1, right. So x of 0 1 plus t of 0 1 where it will map minus of 1 0 minus y of 1 0 and xy. So it is basically x comma minus y or minus y comma x, sorry. Comma x comma y, right. So this will get minus xy plus xy means 0, right. So this is for true for all vector, right. So but the t is non-zero, right, because t of xy is minus yx. So therefore t of v comma v is 0 for all v is in v, but here the t is non-zero linear transformator, right, but t is non-zero. So therefore this, the option number 4 is false. Right. Now let's move to the option number 5. We are saying that norm Tv equals to norm V for all V if and only if inner product of Tv with Tw equals to inner product of V with W, right. So what is it? So this is option number 5. Norm of Tv equals to norm of V if and only norm Tv comma Tw equals to norm V comma W for V or Vw in V, right. So the converse direction is easy. Take V equals to W, right. Then norm Tv square is norm Tv comma Tv. So this is basically norm V comma V. So and this is V square. So therefore norm Tv square will be norm V, right. So this direction is easy. Now for the forward direction, so what we have to show that inner product Tv with Tw equals to V comma W, right. So let's start. So let's start with this. Now Tv V plus W. So this will be norm V plus W, right, as this is given. So left hand side, what is the left hand side? Norm So square it. This is square, so this will be the inner product with T of B plus W, comma T of B plus W, right? So then what it will be? So if you, then you will get TB comma TB plus TB comma TW plus TW comma TB plus norm TW comma TW, right? And note here the vector space is real vector space. Vector space V is over R, right? So therefore, as the vector space is over R, so the bar will be same. So this will be norm TB square plus 2 times norm TB TW plus norm TW square, right? And what will be the RHS? Right hand side. So this is B plus W. This will be B plus W, BW, right? Then what it will be? B inner product B plus B inner product W plus W inner product B plus W inner product W, right? So the first one it will be norm B square plus the again it will be 2 times norm BW plus norm W square, right? Now because these two are equal, so as norm TB plus W, this is square equals to norm B plus W square. So which implies just put both sides and use that norm TB square. So what you will get? So if you put then norm TB square plus 2 times norm TB comma TW plus norm TW square equals to norm B square plus 2 times norm BW plus norm W square. And what it is given? Given that norm TB square equals to norm B square, right? For all B in B. So therefore they will cancel up. Therefore what you will get? Norm TB TW will be norm inner product BW, right? So therefore the option number 5 is correct. Now what is the option number 6? Let T V2R be a linear transformation, then there exists at most one vector V such that TW equals to W inner product V for all W. So this is basically a statement of the uniqueness of the ridge representation, right? That any linear transformation will be look like this, and this vector is unique, right? So this is by the uniqueness we will get at most one vector. So this is option number 6. So T is a linear V2R, TW is W inner product B, right? For all W in B, W. Then by the uniqueness of the ridge representation theorem, by the uniqueness of the ridge representation theorem, B is unique. Therefore, there exists at most one B. Right. So option number 6 is correct. Right. So the question number 3 is done. Now let's move to the question number 4. Right. What you have to solve? It is saying that let Q be a polynomial of degree 2, x square plus bx plus c, such that these two integrals are same for all p in the P2. Then you have to find the value of a plus b. Right. So what it is given? Pt sine pi t is 0 to 1. Pt qt is it is ax square plus bx plus c, so it will be a t square plus bt plus c. So this is for all p. So then what it will be? So it will be 0 to 1. So take it one side, then you will be pt. So this is basically what you will get, sine. But don't need to take it. So as this is true for all p, so just you have to put that the as, so suppose this star is true for all p is in P2R. So let's take pt equals to 1. So then what you will get, if you take pt equals to 1, then the LHS will be, so we will put this pt equals to 1, t and t square. Right. So the first one, when pt equals to 1, then the LHS will be, so what will be the LHS? 0 to 1, it is 1 into sine pi t, right? dt.
Sir, I have a question.
Yes.
Why we are choosing PFT as 1 and then t and then t square?
Yeah, you can take any element. I am just for the convenience I am taking 1 t and t square, because this is hold for all polynomial, right? You can take some t plus t square or something, right? But the calculation will be then more difficult, right?
Okay.
Because this is true for all polynomials in P2R. So whatever polynomial you will get, means they basically for these three, because there are three unknowns, right? A, B and C. So in order to find these three unknown, you need three equations. So in putting 1 t and t square, I will get three equations. So whatever you will put, you will always get three equations. And solving three equations, you will get three unknowns, right?
Okay.
Yeah. So whatever is here for you, you can take. So for the convenience, first I am taking pt equals to 1. Right, then integration of sine pi t, what it will be? It will be minus, so this is 1 by pi, sorry, this will be cos pi t, right? 0 to 1, then what it will be, if you pi it, cos pi is minus 1, cos 0, so it is basically 2 by pi, I think, right? 2 by pi, right? And what will be the RHS? PT 8 square plus BT plus C, RHS will be 0 to 1, it is 8 square plus BT plus C dt. So if you integrate it, you will get A by 3 plus B by 2 plus C, and these two are equal, right? So what you will get, A by 3 plus B by 2 plus C equals to 2 by 5, or what you will get, so 2A plus 3B plus 6C equals to 12 by pi, right? So this is the equation number 1. So putting PT equals to 1, we get one equation. Now we will put PT equals to T, we will get another equation, right? So now B, take PT equals to T, right? So then what you will get, LHS will be integration 0 to 1 T sin phi t dt. What will be the integration of this? So here you have to use the integration by parts, right? So if you use the integration by parts, so let's do it here. Just what you will get, it will be T integration of sin tan minus 1 by pi t cos pi t 0 to 1 minus integration 0 to 1, derivative of t is 1, and it will be 1 by pi cos pi t dt. So if you put 1, you will get minus, this is 1 by pi plus 1 by pi integration of cos pi, this is pi square, and 0 to 1 sin pi t, right? And this is again 0, so you will get 1 by pi. So left hand side we get 1 by pi, and what is the right hand side? 0 to 1 is T 8 square plus BT plus C dt. So then what it will be? It is basically 8t cube plus BT square plus CT, right? dt. So this is A by 4 plus B by 3 plus C by 2. And now equating, what you will get? A by 4 plus B by 3 plus C by 2 equals to 1 by pi, or what you will get, if you multiply by 12, you will get 3A plus 4B plus 6C equals to 12 by pi, right? So this you will get equation 2. Now again you have to put PT equals to T square, right? So now, so again you can put the PT equals to T square, you get a one equation, but in this exercise no need, right? Because just see that you get, so again let me write it, see, you can put PT equals to T square, and you will get one more equation. But for this exercise we don't need, it's from first two you will get, but for this exercise other in other exercise that might need it. We do not need, right? So we will basically from first two will get. So what is the a? What we have to find the value of a plus b, right? So what is the option number? What is the equation 1? 2a plus 3b plus 6c equals to 12b. So just write from equation 1, from 1 what we have, it is 2a plus 3b plus 6c equals to 12 by pi, and from 2 what we have, 3a plus 4b plus 6c equals to 12 by pi. 3a plus 4b plus 6c equals to 12 by pi, right? Just subtract these two to 2 minus 1, then what will happen? So we will get a plus b equals to 0, right? So this is the value of a plus b. So if you do 2 minus 1, you will get this. The value of a plus b is 0, right? So question number 4 is done. Question number 5 is the same question. Here you have to find pi into 2a plus 3b plus 6c. And what is we have got, right? 2a plus 3b plus 6c equals 12 by pi. So from 1 we have, what we have, 2a plus 3b plus 6c equals to 12 by pi. So therefore pi times 2a plus 3b plus 6c will be 12. So the answer will be 12, right? So option number 5 is also done. Question number 5. What is question number 6? So pi into 3a plus 4b plus 6c. So note that this we have got from the equation number 2, 3a plus 4b plus 6c, right? So by equation 2, from 2 we have 3a plus 4b plus 6c, this is 12 by pi. So therefore again we will get pi times 3a plus 4b plus 6c equals to 12, right? So the question number 6 will be 12, right? So you find out all the values. This is question number 4, 5 and 6 is done. Okay, let's move to the then question number 7. Yeah. So question number 7 is the similar type question. Consider the inner product, space P2R with the inner product. This time it is inner product is minus 1 to 1, ft gt dt, and t is a linear operator from P2 to P2 is defined by Tp equals to P double dash minus 2P dash plus P, and it's given that if T star, this is the adjoint of T, it's take 5 minus 7x to ax square plus bx plus c, then you have to find the value of 2a. So this is question number 7, and consequently you have to find the bc also, right? So let's do this. So what is the, so T is a map from P2R to P2R, right? T of P, it is given by P double dash minus 2P dash plus P. So T star again will be mapped from P2R to P2R, right? So, and because this is the adjoint of T, it will satisfy the relation P T star Q equals to TP Q, right? So this is this. So now put whatever it is given. T star q is given a x square plus bx plus c, and Tp is given p double dash minus 2 p dash plus p, right? So what we will then get, and the inner product is what? It's minus 1 to 1. P is the Pt. T star q, what it is? It is a t square plus bt plus c, right? Dt, and what is the right hand side? It is minus 1 to 1. Tp, what is Tp? This is the p double dash t minus 2 p dash t plus pt, right? So this, and what is q? Q is given 5 minus 7x, right? 5 minus. Now you have to again write the last question. So this is true for all p in P2R, right? So again we will put the same like the last question. So put p of t equals to 1 t and t square, right? So first put 1, then what you will get? So case say pt equals to 1. What you will get then? LHS, what you will get? This is minus 1 to 1. This is 1 times a t square plus bt plus c. 1 times a t square plus bt plus c dt, right? So this will be even function a t square by 2. So we will get 2a by 3. This is second one, odd function, it will be 0 plus c, or sorry, yeah, or simply just simplify first, then we will put. So let me simplify the first. Then the computation will be easier, otherwise this will be just right hand side and the computation will be hard. So what you will get? So just integrate it. So the left hand side as it is, minus 1 to 1 pt a t square plus bt plus c dt, or just simplify the first right hand side. RHS, what it is? Minus 1 to 1 p double dash t minus 2 p dash t plus pt, this into 5 minus 70, right? dt. So this you will integrate, then what you will get? So if you integrate 5 minus 70, so the first one, so the 5 minus 70, integration by parts, you will get p dash t, right? Minus 1 to 1 minus derivative of the first one, so it is basically minus 7 minus 1 to 1, and it is the integration, so this is p dash t dt, right? This plus the next one, here again it will be 5 minus 70, integration of p dash t, it will be pt minus 1 to 1 minus, so it will be again 7, and this will be the integration of p dash, so it will be pt, right? So minus 1 to 1 pt dt, right? Plus the last one will be minus 1 to 1, it is remain as it is 5 minus 70, right? So this is by integration of by parts. So then what is, you put 1, you will get minus 2 p dash 1, put minus 1, we will get 12 p dash minus 1. If you integrate, it will p of t, and it will be, so it will be plus 7 p of 1 minus 7 p of minus 1, right? Now here if you put, you will get 1, if you put minus 2 pt, right? Oh sorry, here minus 2 is there. Minus 2 is there, right? So this will get plus 4 p of 1, and if you put minus 1, you will get 12 times 2, 24 plus 24, right? Yeah, plus 24 p of minus 1, and integration of p2. So again, so what you will get then, oh sorry, so no need to do this because these two remain as it is. So what you will get, plus 7 means it will be integration minus 1 to 1, so 7 plus 5, 12, minus 7, so 20, minus 14 plus 5, minus 9, right? Minus 70 dt, right? Is this fine, the calculation, right? So therefore what we will have, yeah, so let's call it star. So then from star, what we have, minus 1 to 1 pt 8 square plus bt plus c dt equals to, what is in the right hand side, let me write it. This is minus 2 p dash 1 minus 12 p dash minus 1 plus 7 p of 1 minus 7 p of minus 1 plus 4 p of 1 plus 24 p of minus 1 plus integration minus 1 to 1 pt minus 9 minus 70 dt, right? Now take the integration one side, or you will get minus 1 to 1 pt 8 square plus b plus 70 plus c plus 9 dt equals to the this one, minus 2 p dash 1 minus 12 p dash minus 1 plus 11 p of 1, and this will be plus 17 p of minus 1, and this is true for all p, right? This is true for all p in P2R. This is simplified, right? So here we will put p equals to, so put pt equals to 1 t and t square. So the first one, a left hand side, what it will be? LHS it is minus 1 to 1, so this will be basically 1 into a t square plus this is b plus 7t plus c plus 9 dt. So if you integrate, what will get? We will get 2a by 3. This is odd function, minus 1 to 1 it will be 0. C plus, so this is 2 into c plus 9, right? So this we will get, and what will be the RHS? If you put 1, then p dash, so this two derivative will be 0, only p of 1 and p of minus 1 will remain, and their constant function, this will be 11 plus 17, right? So this is 11 plus 17, so this is 28. So therefore what will get? So 2a by 3 plus 2 into c plus 9 will be 28. So if you simplify, what you will get? You will get a plus 3c will be 15. So this is 1, we'll call. Now let's put t. Pt equals to t. Then what will be the left hand side? So this is minus 1 to 1. It will be basically a t cube plus b plus 7 t square plus c plus 9 t dt. Now if you integrate it, so if you integrate it, what you will get? T cube minus 1 to 1, this is odd function, so this will be 0, and the last t, it will odd function, again this will be 0, so only middle term will be remain. So this will be 2 into b plus 7 by 3, right? And the RHS, it is what? It is minus 2 times 1 p dash 1, pt is 1, so t equals to 1, it is 1, p dash t again it is minus 12 times 1 plus this is 11 times 1, and this is 7 times pt of minus t, so this is 17, right? Plus 17 times minus 1. So if you calculate this, then what you will get? You will get minus 20. So we will get 2 into b plus 7 by 3 equals to minus 20, or from here you will get b equals to minus 37. So this is 2. Now you have to put the last one. So c pt equals to t square, right? So then left hand side, minus 1 to 1, it will be a t to the power 4 plus b plus 7 t cube plus c plus 9 t square dt. So this is, here again the middle term will be 0 because this is odd function from minus 1 to 1, so only 2 terms remain. So here it will be 2a by 5 plus 2 into c plus 9 by 3. So this is the left hand side, and what will be the RHS? RHS will be minus 2 times P dash 1. So it is minus 2, P dash 1 will be 2 minus 12 times P dash minus 1, it will be basically minus 2 plus 11 times P of 1, it is 1 plus 17 times P of minus 1, it is again 1. So if you calculate this, you will get 48. So what you will get? 2a by 5 plus 2 into c plus 9 by 3 equals to 48. So if simplify, what you will get? You will get 3a plus 5c equals to, you will get 315. So this is 3. So from 1 to 3, what we will get? So let's write it here. So B you will got automatically, right? Because B you have simplified. So let's write it from 1, 2 and 3. What we have got? A plus 3c is 15. B is minus 37. And what we get last? 3a plus 5c is 315. So B we have got minus 37. What is now solve first and the last equation, you will get A. So we will get 3a plus 9c equals to 45 and 3a plus 5c, we will get 315. So what you will get? 4c equals to minus 270, or C you will get minus 135 by 2. Then what will be A? Then A will be, so A will be 15 plus minus 3C, minus 3 times 135 by 2. If you simplify, you will get 435 by 2. Okay, then let's see what we have to find. So A will get 435 by 2. Option number 1, it is, you have to find the value of 2a. So what will be 2a? So then 2a will be 435, right? So what we have got? 2a is 435. So we get question number 7. The value of 2a is 435. Okay. Question number 8. Value of 2b. Yes, value of 2b. B is minus 37. So 2b is 2 times minus 37. So it is basically minus 74. So the value of 2b is minus 74. Now what is question number 9? The value of 2c. C we have got minus 135 by 2. So 2c minus 135 by 2 into 2. So this is minus 135. Value of 2c is minus 135. Right. So question number 9 is also done. And this is the last question. So you have to find the value of ABC. So this is done. So assignment 11 is done. It's finished. Okay, any question?
Sir, in the last question,
Yes.
can be done with this question as finding a linear transformation. Sorry, matrix representation of linear transformation and then matrix representation of T star.
Yeah, that you can also do.
Okay, can we solve this in this method?
Yeah, means so just take the basis and then what will be the linear transform. You can, because the linear transformation is given, right? So if you put t of 1, what it will be? It will be 1, right? So it will be basically 1 0 0, right?
Yes.
Again you put t equals to pt equals to t, then you will get this will be 0 minus 2 plus t, right? So this will be minus 2 in the column, minus 2 1 0, right? Similarly put pt equals to t square, you get the matrix of t, right? Did you understand what I have just said?
Yeah, yes.
Means just apply the basis of P2 under T, you will get the matrix representation of T, then find the adjoint of T under this inner product, right?
Yes.
Okay.
So how to find the T star related with the T?
Okay, T
Yes.
star. So basically it has an expression, right? Adjoint will be inner product with TBB and whole bar, right?
Okay.
Right. This is what is the element? How the elements of group like T star of the matrix. Right. What is the matrix of T? Matrix. What are the element of T? It is so ijth element. What are the ijth element of T? It is T Vj times W, right? Wj. So you can take the, because these are, if they are a standard basis, then they will be the ijth entry, right? Now if you take the bar, you will get ijth entry of T star or jith entry, right? Now again apply, you have to, for all p, here you have to take wj to be all polynomial, means again you have to use the 1 t and t square, and you have to solve 3 equation. Means basically you have to solve this 3 equation, you putting it whatever way you will do, you will get this inner product in the matrix, means entry wise, but again you have to solve this kind of equality, putting 1 t and t square or whatever you take the polynomial. You cannot escape that. Did you get?
Yeah, I have a hint, but I have to work out.
Okay. Try it. If you do not get, I will tell them. You will get it. It will be easier. Means just use this. Ijth entry will be this, and this is given by the inner product, right? You know the inner product.
Yeah, P is the matrix of 1 0 0 minus 2 1 0.
Yeah. So again compute this, means entry wise you will compute the inner product. So use this. So this will be Vj T star, right? So entry wise use the equality. Right? Means you will get this type of system of equation 3 in putting this, and if you solve you will get ABC. Just try it once, you will surely get it.
Can you share this presentation?
Yeah, I will share it. It's in the, I think you will, I have always share it, right? All the files are shared in the drive, and also the videos. You can see it. Let me stop the recording.